Hello, welcome to the HR Diary. Do you know that Best Buy can accurately predict that a 0.1% increase in employee engagement results in an increase in over 100,000 in the store's annual revenue? The enormous impact of engagement prompted Best Buy to make its engagement surveys quarterly instead of annually. Today, I'm going to show you and explain to you what is diversity and inclusion, how to convert diversity into an index, and how to predict the impact of diversity, equity, and inclusion, which is DEI, on income in Excel with multiple regression. Now, what is diversity, equity, and inclusion? Diversity is the who, inclusion is the how, equity is about fairness in policy and practices. So diversity is the who. Diversity are like puzzle pieces in all shapes, sizes, and colors. Diversity describes measurable people differences such as gender, age, and race. It describes who are in that department, who are recruited, who are promoted, who we are monitoring. Inclusion, on the other hand, is the how. Inclusion happens when all these puzzle pieces come together as one into this. Inclusion is about how people feel. Inclusion is about how does the company include different people. Are all staff given training opportunities? Are all staff invited for team lunches? Is the staff asked for their views? Equity is about fairness in policy and practice. To have equity, we can't use the same boxes for all employees. Equality is about sameness, the same size boxes, while equity is about fairness. Equality pushes those who are furthest behind even further. Employee want fairness in contributions and rewards. They want fairness in the inputs and the outcome. So I've explained what is diversity, equity, and inclusion. A short form is called DEI. Now let's move on to the next topic. How to convert diversity into an index. It's here. All right. Most companies measure diversity, example, gender, using traditional breakdowns like 50% male, 50% female, or ratios. Or 5% females, 95% male. Such percentages are difficult to measure the shifts in diversity representation across the company. We need to convert all these percentages into an index like this. So here, the diversity is half-half, 50-50, so the index is 51. In company B, males are much higher than female at 95, while female is 5, so the diversity index is lower. So at one glance, this number, you can see which company has a higher diversity index, which has more diverse. So how do you convert all this into this? So here is my formula, here. And this formula, I have shown it in here, the column F formula. And then this one is I use referencing. The column G formula is here. So this formula is using this Simpson's diversity index. The Simpson's diversity index can be used to quantify diversity into a trackable matrix. Simpson's diversity index started out as a tool for measuring species diversity, but here I will use it to measure workplace diversity. The formula to compute Simpson's diversity index is this. And the small n here refers to the number of individuals of each gender. The capital N refers to the total number of individuals. So in company A, the big N is this 100. So 100 times 100 minus 1. All right, this is what I mean. And then the small n. So if you look at this formula, this is the big N. This is the N minus 1, 100 minus 1. And this small n here is this 50 is the number of females 50, and then 50 n minus 1, so 50 minus 1 is 49. And then next, this is the male. So this is the female, this is the male. Male is 50 or so times 49. So let's look at another example here. How I convert this number into the gender diversity index. So 1 minus 5. Here's 5 times 4 because 5 minus 1 is 4. And then next, male is 95. So 95 times 95 minus 1 is 94. And the denominator is this n 100. So 100 times 100 minus 1 is 99. So this is the formula. So I've shown you how to convert this into a gender diversity index. So with all this data here, I have converted. So this is my raw data. I've converted it into a gender diversity index. All right. This number is the same as this number. Right. So this is the formula. You can see that my formula is, I place it here. This is the converting this into this. So this has the highest gender diversity index. This, where there's no females and 100% males, has the 0 gender diversity. This has a lot of males, 80 males and 20 females, so the gender diversity index is also low. All right. Now, let's get back to explaining this Simpson's diversity index. The Simpson's diversity index captures two elements of diversity: richness and evenness. Richness refers to the number of different groups represented. So the more gender group represented in a sample, the richer the sample. It does not consider the number of individuals of each gender. So these two companies, they have the same richness because they have both male and female. So all these companies have male and female. All right. Whereas this company here has lesser richness because it doesn't have female. Evenness refers to the spread across the groups. So are the gender group spread evenly? It considers the number of individuals in each gender group. In the Simpsons index, both richness and evenness are important, and they are incorporated in a single clean shot in this index. Your company is not diverse if only one gender is represented compared to two gender groups. So for example here, this company only has male. So it is not diverse. So it is not rich. All right. And if you have 5 female, 95 males, you have low evenness. This company A have high evenness. This one has low evenness. So here, assuming there are two companies, company A and B. Company A has 50 females, 50 males. Company B has 5 females, 95 males. Both companies have the same richness because both have two gender groups, male and female. And they have the same number of employees, 100, 100. But company A has more evenness than company B. This is because the total number of employees in company A is evenly distributed between the male and the female. Whereas company B, most of the employees are male, and there's only very few female. So company B is considered less diverse than company A. Before we can perform multiple regression in Excel, you need to install Analysis 2-part, which is an Excel add-in program that provides data analysis tools. So you need to install it here. And here's how you do it. Go to the file, go to click more, options, click onto add-ins. So make sure you select add-ins and click go. Check Analysis 2-part and click OK. Once you click OK, you will see that Analysis 2-part appears here. All right, so it appears here. Now we're able to click this. All right, so in this example, we want to predict the impact of DEI on income. The impact of using Excel with multiple regression. So what is multiple regression? Multiple regression is a statistical technique used to understand the relationship between one dependent variable and two or more independent variables. Here, I want to predict the impact of advertisement, equity rating, inclusion rating, and gender diversity index on income. So my dependent variable is income. My independent variable are these four: advertisement, equity rating, inclusion rating, and gender diversity index. Now let's run multiple regression. To run multiple regression, go to the data menu. All right, make sure you click this, and then click onto this data analysis. Look for regression. From the list, select it, click OK. After you click OK, you have this dialog box. You will see this regression dialog box. For input Y range, select the column including the header with your dependent variable income. Click back to this. For the input X range, select the columns including the header with your independent variables, advertisement, equity rating, inclusion rating, and gender diversity index. Check on labels because earlier I selected all the labels or what you call all the headers. And I want to tell Excel not to take these labels not to use it for calculation. Now check on the output range. Click onto here and choose where you want output to appear. So I want it to appear here. So I click onto here, click back here. And once you click OK, you will see the output appear here. So let's click onto OK. And here you have the output. Now, there's too many decimal points. So I want to select this output, go to Home, select number, and put it to 3 decimal points, which is easier to see. So now, how do we interpret this summary output? I will highlight a few useful numbers for our purpose. R square. In the output, my R square is equals to 0.998. This means that this model is a very good fit. It means that 99% of the variation in the output, which is income, is explainable by the independent inputs, by all these independent inputs. The closer R squared is to 1.0, the better the regression line fits the data, the better the model for prediction. Next, significance F. To determine if your results are statistically significant or reliable, check this significance F. If the value of significant F is less than 0.05, it is statistically significant or reliable. If the value of significant F is bigger than 0.05, review the p-values that is bigger than 0.05. Next, let's move up here. Let me make it a bit smaller. All right. This is the formula for multiple regression. What this formula is saying is that the y variable depends on all these x independent variable. The y dependent variable depends. Let me space this a little bit so you can see. Right? The y dependent variable depends on this x dependent variable. So the y dependent variable is income. The y dependent variable income depends on the x dependent variable, which is all this, the advertisement, equity, inclusion, and rating. So y is income, x is advertisement, so B1 is the coefficient for advertisement. So X2 is equity rating, X3 is inclusion rating, X4 is gender diversity rating. All right. So you see B1 is here, X1 is here. So like what I said, y is the dependent variable. In this example, y is the income, and y is what we are trying to predict. The X1 to X4, they are the independent variables. We are using X is what we are using to predict Y. So in this example, these are the X. And all the B1, B2, B3, B4, they are the coefficients for each of these independent variable. B0 here is the constant for the intercept. Next, let's build our multiple regression model for prediction 1. All right, let's adjust this so you can see. And these coefficients here, all these are the numbers that we need. We need to fit all this into this formula, which is here. All right. So plug in the intercept coefficient number, this number, plug it here. The advertisement coefficient number is this. The equity rating coefficient is this. The inclusion rating coefficient is this. And the gender diversity index coefficient is this. So you see my regression formula is this. This formula here. This formula looks like this formula. And this formula takes the number from this table. So I've also shown the formula in column M here. So you can see. So this formula M20 is like the coefficient. Then this multiplied by this times this, multiplied by this times this, multiplied by this times this, and multiplied by this times this. And you get the income. This income formula. Now let's do the same for this prediction 2. We'll take in the same numbers. All right. Now we have done this. Let's make our prediction. Now I want to predict the effect of advertisement, equity rating, inclusion rating, and gender diversity index on income. So if advertisement is 800, if I spend 800 on advertisement, and if my equity rating is 7, if the inclusion rating is 7 and gender diversity index is 0.3, you'll get an income of 925. Let's put in the same number here. 800, 7, 7, 0.3. You get the same number because I'm using the same exact formula. All right, the same model. Okay, let's make this bigger so you can see. Now, if I increase my advertising budget from 800 to 2,000, what happens? When I spend more on advertisement from 800 to 2,000, my income increases from 925 to 1,306. Now let's put this back to 800. Now my equity rating is 7 and my income is 925. So if employees' perception of the equity increases from 7 to 9, the income increases from 925 to 1,100. Let's revert this back to 7. Now let's try this on the inclusion rating. So inclusion rating 7, if we change this to 9, the income also increases from 925 to 931. Let's revert this back. And let's try another example. Gender diversity index. So if gender diversity index increases from 0.3 to 0.5, your income increases from 925 to 1,001. So I've shown you the model. So this is the formula here. All right, that's it. In this video, I've shown you how to predict the impact of diversity, equity, and inclusion on income in Excel using multiple regression. Thanks for watching. If you are not a subscriber, click down below to subscribe so you get notified about similar videos that we upload. Don't forget to like, share, and subscribe to the HR Diary channel.